Okay. No, my bad.
Okay. This is our final talk, and we are doing the chemistry of milk. I'm Julia Geer.
I'm Zoe Ford.
And I'm Joseph Oliveira.
Today, we're going to talk about a few different examples of milk chemistry, including what milk is, what it is made of, and how this translates to a chemical structure. Additionally, we will answer some questions by applying things we have learned in this class. So, what is milk? Milk is an opaque white liquid secreted by the mammary glands of mammals with the objective of feeding the newborn and guaranteeing the intake of essential nutrients. Additionally, it has a chemical composition that is quite complex and can be affected by factors including climate, stage of lactation, and the cattle's age, health status, diet, and breed.
Okay. What is milk? Milk is primarily an emulsion, which is fat globules in water. These factors make milk a colloidal solution. A colloidal solution is when matter exists in a state of division, intermediate to true solution and suspension. It is said to be in a colloidal solution or colloidal suspension. Some basic characteristics of a colloid are small particle size, electrical charge, and affinity of particles for water molecules. In addition to being a colloid, milk is also three things: a solution, a suspension, and an emulsion. A solution is a liquid mixture in which the minor component, the solute, is uniformly distributed within the major component, a solvent. A suspension is a heterogeneous mixture of fine solids dispersed into the liquid phase in which they cannot be dissolved, but kept suspended, even if it is made out of the microscopic solid particles. And an emulsion is a suspension of droplets of one liquid in another. We learned about solute and solvents in our Chem 110 class. Milk and cream are also examples of fat and water emulsions, and the milk fat exists as small globules or droplets dispensed in the milk serum. The emulsion is stabilized via a very thin membrane, and milk fat consists of triglycerides, fatty acids, steroids, carotenoids, and vitamins A, D, E, K. Milk fat is a liquid when milk leaves the udder. This means fat globules can easily change their shape. For the substance breakdown, cow's milk is a complex polydiverse system consisting of about 87% water and 13% dry substance. This dry substance is suspended or dissolved in water. It can result in diverse types of the distribution in the aqueous phase. Organic compounds found in milk contain carbon, oxygen, and hydrogen. These visuals are a milk composition graphic. C2H5OH is the molecular formula for milk, and below is the structural formula for milk. We learned how to draw these structures in Chem 110, and we also learned how to balance equations and find out what these equations compose. These structures are partly what composes milk.
Can you go back one slide? It skipped one, I
My
think.
bad.
So here we have the substance table breakdown. So as mentioned before, milk is mostly moisture. This table shows that it is 87.5% moisture, 3.9% fat, 3.4% protein, 4.8% lactose, and 0.8% minerals. It also includes some emulsions, true solutions, and is a colloidal solution and suspension. And the next visual talks about the particle size in milk. This includes the fat globules that were mentioned before, casein, calcium, phosphates, whey proteins, lactose salts, and other substances in true solutions. And once again, as mentioned before, these particles complete the composition of milk and um, combines with the physical chemical status to create the beverage and the nutrients that a child needs. Next up, I have a slide for chemical and physical properties of milk, which we have discussed in Chem 110. Starting with the chemical properties, we have the composition, we have pH, we have buffering capacity, and for physical, we have density. The approximate milk fat density is about 902 kilograms m cubed at 40 degrees Celsius. There is another physical trait is specific gravity, also known as relative density. We have freezing point, viscosity, substance and interfacial tensions, and light absorption, and refractive index. This next slide is questions I thought could be answered by chemistry, some relating to what we touched on in Chem 110. So first off, why is milk white? Milk is white because it contains micelles, I think is how you pronounce it, but they scatter light, which causes milk to appear white. Secondly, is milk an acid or a base? Milk is kind of in that middle ground of being neutral, but it is slightly acidic and has an average pH of 6.4 to 6.8. And does milk have electrons? Yes, it does. Everything made of atoms has electrons, and it is made up of, proteins and fats and all that that do contain atoms. All right, and here are our sources. All right, thank you.
All right. Oh wait, I'm still recording.